Good morning, friends. Today we are going to see the very important concept of statistics, that is correlation. First of all, we'll see what is bivariate data. As we know, the relationship word exists for two variables. Whenever you use the word relation, there must be two human beings, but we are defining the data. That's why correlation is the term which is used for bivariate data. So to understand bivariate data, first of all, you should be able to understand what is bivariate data. So the term bivariate data can be defined by paired observations. For example, if I want to study the correlation between the electricity consumption of a family and electricity bill, then it will be a bivariate data. N number of pairs of different families we have to take, and then we can study the correlation between the electricity bill and electricity is going to increase. So what kind of, in other example, suppose if I will take the price and demand. As you know, in market always we study if price is increased, demand of any commodity is decreased. So it is an example of negative correlation. Negative correlation, how you define? When one variable is increased, the other variable should be decreased. The change will be in opposite direction. So now, first of all, what we have seen? Correlation and then type of correlation. So I hope you have understood the correlation term and type of correlation, positive and negative correlation. But this is all about theoretical part of theoretical definition of correlation. But practically how to measure it and how to give a quantitative answer for any correlated data. So for that, there is a very popular method, or you can say a formula, which is called a Karl-Pearson's correlation formula. And scatter plot, already I have told you, scatter plot is a method in which graphically you can visualize the correlation. You cannot get any quantitative answer, but you can visualize the correlation, and you can, after plotting the values on the graph paper or using any software, you can get an idea of type of correlation, means whether it is positive, whether it is negative, or is there any relationship or not. Means it is possible that there is no relationship, means correlation is not there, no correlation case is also there. So first we will see what is scatter plot. Scatter plot is a very simple term, or we can say it is a graphical, because I have a bivariate data. One variable I will plot on the x-axis and the other variable I will plot on the y-axis. If I'll get this kind of straight line which is going exactly upward direction, this is an indication of positive correlation. But always I will get this kind of shape? No. It may vary. It depends on the data. Suppose if I'll get this kind of straight line after plotting the data, then this is an indication of negative correlation. Okay? Maybe these values scatter in some percentage. For example, I am getting the values on upward direction, but some of the values are scattered. Even then, I can understand that the correlation is positive, but the percentage of correlation or degree of correlation is less. In the previous case, it was 100%, but here it may vary approximately 75%. But the type of correlation will be positive. Rho I have written x square and then y square and xy. Why I have written like this? Because I want to calculate the value of r, for which I want the covariance of xy, sigma x, sigma y, and for that calculation I need this calculation table. X square means what? the column of x values are squared here, means all the values of x are taken square here. 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16. Like this, y square column is also prepared. Similarly, xy is the column in which we are multiplying the column of x with column of y. Why I am doing this? Because I need this. In detail we will see further. xy is the column where I multiply the first column and the second column, and the product term I will write here. 1 is first value of x, x1 is multiplied by first value of y, that is y1. 1 into 2, 2, 2 into 4, 8, 3 into 6, 18, 8 into 4, 32. I have written all these values in this column. Now using all these columns, total I will get the respective term 5. So here it 2.23 for the sigma y. Now I have got 2.5 as covariance of xy, sigma x as 1.1, sigma y as 2.23. Now we will go to the final formula and we will see what is the value of approximate value of r. So covariance of xy is 2.5, in the denominator sigma x, sigma y, if you will see, it is 1.1 and approximately that is 2.23. So it will be final answer after cancellation will be approximately equal to r, which is the indication of 100%, approximately 100% positive correlation. Okay. So